Hi students, I hope everybody doing well. We are we are learning solid state. In last two videos, we are discussing about crystalline solids, amorphous solids, differences. After that, types of crystalline solids and the examples we discussed. In this video, what we are going to learn is some terminology in this solid state. What type of terminology? See here. Here, what is there here? Crystal lattice and unit cell. Mainly crystal lattice, this one, and unit cell, this one. See here, crystalline solid, crystal lattice, and after that this crystal. All these three are same only. Four all same. Crystalline solid, crystal lattice, after that crystal, all are same only here. See what is this crystalline solid? Already we discussed crystalline solids, amorphous solids. Solids are how many types? Solids are two types. One is crystalline solids, other one will be what is amorphous solids. Amorphous. Now we are talking about crystalline. In this crystalline solids, what is it? There is a regular arrangement. Long range order will be there, regular arrangement will be there in a three-dimensional pattern. That is what crystalline solid. How they are giving? This is the definition from the textbook only directly. Crystalline solid is characterized by definite orientation of atoms, ions, molecules relative to one another in a three-dimensional pattern. You see, this is a three-dimensional crystalline solids, I can say. Crystalline solid I can say, otherwise crystal I can say. Three-dimensional, there is a regular arrangement of this. What is this? Pink color. This balls are there, no? These atoms are there. We can say these are atoms. Generally, these we can say as a atoms. Otherwise, we can say as a molecules. Otherwise, we can say as a ions. All these combinedly called as lattice points. All these combinedly called as lattice points. In this crystalline solid, there is a arrangement of atoms, molecules, ions in a three-dimensional pattern with a definite direction, definite orientation. This is what crystalline solid. Crystal lattice. Yes, the regular arrangement of these pieces. These pieces means what is that? These pieces means atoms, ions and molecules only, again throughout the crystal. Is a crystalline solid, otherwise a crystal. This crystal fully, what is that? Arrangement of atoms only. That is what crystal lattice. Crystalline solid, otherwise crystal lattice, and other one will be what other one? Crystal. The crystal may be considered to consist of large number of unit cells. Okay, we will talk about unit cells, then I will talk about a crystal. This much solid is there, this much crystal is there, this much crystalline solid is there, this much crystal lattice is there, this much what has to form? This much solid has to be formed. So how it is going to form? This is the this many cubes are there. You can observe here many cubes are there. All these cubes, this is a very big cube. This is a very big cube. That very big cube is a combination of the repeating unit of small cubes. See here, this is one cube, and after that, what is that? This is one cube. You see, this and all is a one cube. After that, this is one cube. You see, I am writing here. You can observe. That's what I am writing on this. This is one cube. So many cubes are there. First layer cubes and second layer cubes and third layer cubes. So this cube only repeatedly arranged in a three-dimensional pattern. This is what the smallest, the basic repeating unit, the basic repeating structural unit of a crystalline solid. fully crystalline solid, we can say. In that crystalline solid, the basic unit is called as unit cell. This is the unit cell. This is the unit cell. This is also having a three-dimensional format only. This is like x-axis, this is like a y-axis, this is like a z-axis. This is what unit cell. And now what we can say, all these unit cells, this is one unit cell, you can say this is one unit cell, this is second unit cell, this is third unit cell, this is fourth unit cell. Again this is fifth unit cell, this is sixth unit cell, this is seventh unit cell, eighth unit cell. And this is ninth one, again 10th one, again 11th one, again 12th one. Similar way that side also. What is that side? Other side also, back side also, one back side, one more. This is 1, this is 2, that cube, third cube, fourth cube back side. Again this fifth cube back side, fifth cube, sixth cube, seventh cube, eighth cube. Other same, ninth cube back side, ninth cube, 10th cube, 11th cube, 12th cube. For example, this is a crystal, means this is the combination of, this is the repeating of how many cubes? Almost 9 plus 9. How many? 9 plus 9. That is equal to 18 cubes. That the smallest one cube is you are calling as a unit cell. That is what unit cell here. And the next term is coordination number. What is this? Coordination number. Coordination number means what? The number of nearest neighbors that surrounding a particle in a crystal is called the coordination number of the particle. For example, I will take another crystal. See here, this is a very fresh. This is a very fresh crystal. We will talk about here coordination number. What is this coordination number? Coordination number means this one I am taking, this one I am choosing, this atom I am going to choose. How many neighbors are there? See, neighboring atom. This is having how many directions? For example, it is a x-axis, means it is x-axis, means it is a y-axis, means it is a z-axis. So three-dimensional is there. How many neighbors are there? How many neighbors are there? You want to calculate the neighbors. See, x-axis. This is my particle. I am choosing this one, and neighbor one, this one. Same axis 1. In the same axis 2. Y-axis. Above one, this is third one, below one, this is a fourth one. Z-axis, this is Z-axis. Here 4 over, no, this is fifth one and this is a sixth one. Observing or not? Here in this crystal, atoms are arranged. One atom I am choosing. I want to find out the coordination number for this atom, means I have to count the number of neighboring atoms which are connected to this one. Here this is arranged in a three-dimensional way, so that x-axis, on this x-axis this side one atom is there, that side one atom is there, y-axis above one atom is there, below one atom is there, z-axis this side one atom is there, this side one atom is there. Counting means, what is the count here? 1, 2, 3, 4, 5, 6. So coordination number of, for this one, coordination number will be, for this black color atom, the coordination number will be 6. This is what the definition of the coordination number. And now see this unit cell, we discussed about the unit cell. This is the smallest one, is unit cell. This unit cell, again we have two types. How many types are there? Two types are there. First one is primitive, and the second one is non-primitive. First one is primitive and second one is non-primitive. First we are going to learn primitive. Here generally, general means primitive. Whatever the unit cell you are taking, it is having a one lattice point, but it contains only one lattice point. It is our textbook definition. It is called primitive unit cell, which is made up from the lattice points at each of the corner. For example, you see, this is the cube. This is the cube. In this cube, here one atom is there. What is that? See here. What is there? In this, here one atom is there. Here one atom is there. Here small dot is there, no black color dot. that is atom. Here this corner one atom, this corner one atom, this corner one atom, this corner one atom. Logically we are going to think means this side also one more cube will be there. Side by side cubes are there. This whatever the atom is located here, this atom completely not belongs to this cube. This is also present in the neighboring cubes also. Like that, how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners, 8 atoms are there. Each atom completely not belongs to this cube. That atom also present in remaining other 7 cubes are there. This cube plus other 7 cubes are there. It is going to present in 7 other cubes. So that it is sharing by one atom present at the corner can be sharing by 8 other cubes. Totally 8 cubes sharing. So this part, this cube is getting a share of 1 by 8 of this 1 by 8. This atom is present in this cube. How much part? 1 by 8 part. Like that, how many corners are there? 1, 2, 3, 4, 5, 6, 7, 8. Into 8, like that 1. It has to come like this. Then this is called as a primitive. And generally what we can say is, in primitive, what is that? In primitive what we can say is, in primitive all the atoms are located, mainly are located at the corners. Here. Whenever in any unit cell you are taking means, how to identify that is a primitive or non-primitive? If that unit cell one cube is there, in that cube atoms are located at the corners. These are the corners, 8 corners. Here in this corner positions atoms are located means you can say that is a primitive. It is also other definition. And our textbook what they are saying, in the unit cell one lattice point must be there. You will get a doubt. Here 1, 2, 3, 4, 5, 6, 7, 8 atoms are there. How can I say that is a primitive? Here what I am going to say is, observe, just observe. I will take a very big cube here. See, for example, this cube you take. See everybody, observe carefully. I am explaining here how that one will come. Here this cube is there. This cube. This what is that? This atom is there. This atom is present in is in connecting with how many cubes? See, this atom present in this cube. 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 In a similar way, top also cubes are there. This also present in this cube. See, this one is there now. How many are there? This one. Above also 4 are there. 1, 2, 3, 4. Below 4 are there. Above also how many are there? The 5, it is 6, and that side, back side, that is 7. This side 8. So 8 here. 2, 3, 4. 8 cubes below. Similar way what I can say? 8 cubes above. At the center, this atom is there. This atom is at the center. So this atom is present in 8 different cubes. So each cube, what is the contribution getting? 1 by 8. Like that for each unit cell. This is the unit cell. How many corners are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners are there. From each corner, atom contribution to the unit cell. From each corner, atom contribution to the units 1 by 8. 1 by 8 into 8 is coming as a 1. So effective number of atoms present in this unit cell is 1 only. Even though 1, 2, 3, 4, 5, 6, 7, 8 atoms are occupying 8 corners, but all the 8 not belongs to this unit cell. From each corner, 1 by 8 part of atom only presenting in this unit cell. Like that, 8 corners are there. 8 corners are there. From each corner, 1 by 8 part coming, so that it will be 1. So effective number of atoms, real number of atoms, exact number of atoms present in this unit cell is 1 only. So that it is called as a primitive cell. And after that, what is non-primitive? Non-primitive means easily what we can say, in case of non-primitive unit cell, there are additional lattice points either on face of the unit cell or within the unit cell. What is that? Non-primitive means whatever the primitive condition is there, that will be there. What is the primitive condition? Primitive means in that particular unit cell. This is my unit cell. This is a one unit cell cube. This is one cube. Here all the corners are occupying. This is a primitive cell, primitive unit cell. In addition to this must be there. In addition to that, the lattice point may be present on the faces. How many faces are there? For a cube, above one face, below one face. This side one face, this side one face. Back side one face, front side one face. So overall, in a cube, how many faces are there? 6 faces are there. This also called as a non-primitive. Otherwise my cube is there as usually. My cube is there. My unit cell is there. All the corners are there. All the corners occupy means this is a primitive. In addition to this corner lattice point, additionally at the center of the cube is like this. 1, 2, 3, 4. Observe. What I am saying, observe here. 1, 2, 3, 4, 5, 6, 7, 8. 8 are there. 8. This is primitive. In addition to that, at the center what is there? Observing now, at the center what is there? At the center one more is there. This is called as non-primitive. In non-primitive, we are going to study 3 different unit cell. That is body center cubic cell, face center cubic cell, and end centered cubic cell. These 3 types we are going to study in a non-primitive. But in a primitive one, only one thing only you are going to study. This primitive we can also say as a simple cubic model. Simple cubic unit cell. Simple cubic we can say that is coming under primitive. All the corners only occupied means simple cubic, otherwise primitive. Otherwise effective number of lattice points must be 1. That time you can say this is a primitive. Non-primitive means what we can say? Non-primitive means here in addition to the corners, there will be a lattice points occupying in the center of the faces. Otherwise body center. At that time we can say this is a non-primitive. This non-primitive we can study 3 ways. One is BCC, body center cubic cell. Other one is FCC, face center cubic cell. Other one is end center cubic cell. These 3 ways we can study. Now you see here, what is there? Here this primitive only. There are in this primitive only 7 types are there. 7 types. See, cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, hexagonal. All these you are observing means all the corners in this cubic, all the corners only occupied, you observe. In this tetragonal, all the corners only occupied, you observe. Orthorhombic also corners only occupied. Monoclinic also corners only occupied. All these 7 crystal systems, how many? 7 crystal systems are there in a primitive unit cell type. And to remember that easily, what is the method? How many are there? 7. 1, 2, 3, 4, 5, 6, 7. This one we are going to remember in the name of CTO, MTRH. Like this you can remember. Why I am following this order? I am not following the textbook order. I am following CTOMTRH. See this. Whenever I am talking about a unit cell, whenever I am talking about a unit cell, this is a unit cell. In this unit cell, what is there? In this unit cell, what is there? One axis, x axis is there, y axis is there, otherwise z axis is there. Three dimensionally x, y, z axis are there. And the angle between these two axes you consider as a, what to say, alpha. Angle between this y and z axis you consider as a beta. Angle between x and z axis you consider as a gamma. These three are the angles now. So that this A, B, C parameters come here again. That system can be decided by the name of the system: cubica, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, tetragonal. This system can be explained based on the unit cell parameters. See here, why I am following this order. See, A is equal to B is equal to C means that is, and alpha beta angles, alpha beta gamma is equal to 90 means that is coming under cubic. See here, cubic here observe means all the lengths are equal and wherever you see angles are 90. And the next one, tetragonal, A is equal to B, B not equal to C. Observe, tetragonal, A and B are equal, but C, this lengthy line is not equal. So like that, for everything you can observe by the diagram. See here, why I am following this order? See logic, A, B, C, alpha, beta, gamma, all are equal to are there here. Next one, tetragonal, A is equal to B, not equal to C, here not equal to coming. Orthorhombic, see here not equal to, one more not equal to coming. Here I am not going to change anything. Then monoclinic, all the not equal, and here beta separately not equal to 90. Here not equal to here two not equal to are coming. Here two not equal to plus one more not equal to coming. After triclinic, here not equal to, everything is not equal to. Up to this we are following one order. This rhombohedral and hexagonal, no logic. Here we have to follow A is equal to B is equal to C and alpha is equal to beta is equal to gamma, but not equal to 90. This one you have to remember. Again hexagonal, A is equal to B, not equal to C, and alpha beta is equal to 90, gamma is equal to 120 because AB are equal. So alpha beta is equal to 90, C not equal, so that the gamma value will be 120. All these things we have to remember. In this one, all the examples are not required. Here many examples are there. All the examples are not required to remember. Here NaCl, zinc blend, graphite, these are very well known examples. This remember means okay, if you are capable to remember, you are remembering, you can remember, but question will come on this. In the NEET exam and all, what type of question can come? What type of question can come? They will give these parameters to you. Alpha, beta, gamma values, ABC values, they will give it to you. Based on this only you have to say which crystal system it belongs to. CTOMTRH is there? No, CTOMTRH, cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral and hexagonal. It is, we can decide the crystal system name based on the unit cell parameters. The question will come for NEET based on the parameters. Very rarely examples they can ask. This is the discussion in this video. We will go for next video with another content. Okay, no? Yes.